Hello students, I am Dr. Noor Danish and I am going to deliver this lecture on the wave velocity or phase velocity. Now, actually the waves are propagating, and what is wave? Waves are actually disturbance in the medium. Now, if a disturbance is produced at one point, consider it moves from one point to another point by when it vibrates. The first particle vibrates, it makes disturbance in the second medium, and then the second particle moves disturbance in the third medium, and hence in this way the wave propagates from one place to another place. Now means the wave is moving with some velocity, and for this there are two types of velocity. One is called phase velocity and another is called group velocity. In this lecture you are dealing with the phase velocity. What is phase velocity? The phase relationship between the disturbance particle in terms of wave and the velocity with which the plane of constant phase propagates through the medium is known as wave velocity or phase velocity. Means the particle of the what is in phase propagation, okay, through the medium will be called phase velocity. Now equation for the plane progressive wave is given by y is equal to a sin omega t minus kx. You are well aware of this equation where a is the amplitude, omega is equal to 2 pi upon t is equal to 2 pi into nu angular velocity, and k is the propagation constant, and the term, okay, omega t minus kx represent the phase motion, okay, it represents the phase motion. Hence for the plane of constant phase, as in the statement I said constant phase motion, and if it is constant, omega t minus kx is a constant. Now differentiating this omega t minus kx with respect to time, we get omega minus k dot dx upon dt equal to 0. This gives me dx upon dt is equal to omega upon k and is represented by u, and which will be called phase velocity. Thus the phase velocity omega upon k is the velocity with which a plane progressive wave front travels. Thus what I am finding? A velocity u given by omega upon k, ratio of the omega upon q is the velocity with which my phase is propagating. Now there is a question whether the particle is propagating with the same velocity or with a different velocity as the phase. Let's see it. Okay. If lambda is the wavelength of the wave and nu is the frequency of the wave, then from the equation we know u velocity will be equal to lambda into frequency. Since we know E is the energy of the wave particle, and as we know E is equal to h nu, and thus nu will be equal to E upon h. Also from the de Broglie hypothesis, the theory of wave nature, lambda is equal to h upon mv. Therefore, the phase velocity of the associated de Broglie wavelength will be u will be equal to nu into lambda is equal to E upon h into E upon mv is equal to E upon mv. But from the Einstein relation, we are aware E is equal to mc square, and when we put the value of E here, u is equal to mc square upon mv is equal to c square upon v. Now we know the velocity of light is much more than the velocity of the disturbance. So c is very greater than v. Therefore equation 2 implies that the phase velocity of the associated is greater than the velocity of the light. The associated wave travels, thus the associated wave travels faster than the particle, leaving the particle behind. So what is possible? That the phase is moving at a much higher velocity compared to the particle, and thus leaving the particle behind, and the phase velocity can even be greater than the velocity of the light. However, nothing is moving with the faster than the velocity of no physical thing is moving with the more velocity than the light. Thus, this phase velocity is a purely mathematical idea to the associated with the wave. However, it has got its own importance. In the next lecture, you will be learning group velocity and then how phase velocity and the group velocity are two different things. Okay, thank you for listening, and moreover subscribe my channel. You can get information directly from YouTube. Okay, thank you.